Hello again. Tonight we're going to talk about how you cool the Earth down by blocking the sun. And don't think extremes at this point. Just think of it's a process, it's physics, and we'll get into the minutia of how to do it and what scales to do it and such. So if you've ever partaked of a total solar eclipse and you were standing there on the ground when the shadow of the moon passed over the Earth, you'd notice that, hey, it got cooler for a little while, for about 4 minutes, and then it got back to being warm again. And so that's what completely blocking out the sun over a very small area can do. But it doesn't last for very long because, the Earth is going around the sun. The sun is being blocked by the moon. The moon is going around the Earth. So the shadow is going over the surface of the Earth at about 1,000 miles an hour or 1,600 kilometers per hour. The actual speed varies based upon your latitude, where you are on the Earth. But the diameter of the shadow is only about 93 miles or about 150 kilometers. That's the penumbra, the darkest part of the shadow. There's an umbra, there's a not quite full shadow that's larger than that. What you can see is that if you blot out the sun by a certain percentage, you can reduce the temperature on the Earth in a specific area. So that's kind of like, how would you do this as kind of mankind creating technology and offering a service? How would you do this? As Helen would be out to make a presentation, it's all about sizes and distances. The distance of the moon away from the Earth and the distance from the Earth to the sun and the diameter of the moon at that distance, there's a 40-to-1 ratio, and that allows the moon at that distance to completely block out the sun for a limited space on the Earth. The moon's orbit around the Earth is slightly tilted, so we don't get a total solar eclipse every lunar orbit, every 29 days. We get them less frequently, maybe once or twice a year, and rarely in the same place on the planet. In order for the moon's shadow to completely cover the Earth diameter, it can't cover the whole Earth because on the other side of the Earth is darkness, that's nighttime. You can only block out the sun during the daytime. If you said, I want to block out over the whole hemisphere of the Earth, that would require something at a distance that's farther away, and it would have to be many times larger than the diameter of the moon to cover the entire hemisphere of the Earth. So that's kind of an impractical thing. I don't think we have the technology for it. But what if we said, if we made it farther away and not the whole hemisphere, we just covered like, North America or the US or whatever, could we make that technology? The problem is when you move your obstruction disk that far away, the light will diffract or bend around your disk, and you won't get as dark a shadow as you want. You have to put like another ring around the outside that deflects away the diffraction in order to make the center darker, but that will reduce the diameter of your obstruction. So that again gets to be a problem. And the second thing is, if you put it that far away from the Earth towards the sun, then it's got to have propulsion, because things that are closer to the sun orbit the sun faster than the Earth orbits the sun. So now you have a propulsion problem. So it's not just, well, let's put a sunshade up there. Okay, bigger, smaller, where, farther, nearer. You have all these factors to deal with. The other thing we can think about is, how do we make this thing such that it makes the Earth darker, and how long can we do that for? If you're aware of the NASA NOAA GOES, the weather satellites that they put up into orbit at geosynchronous, even at geosynchronous, the satellite only lasts about 5 years before it runs out of maneuvering fuel and gets put into a parking orbit, and you have to send up another satellite. So if you wanted to do this on an extended period of time, where would you put it? How far up would it need to be? And how often would you need to repair or replace it? So there is a place in space, Lagrange points. There's one called L1 that is between the Earth and the sun. It's a gravity stability. It's kind of like a roller coaster ride. If you're in the right spot, then you can kind of be in a stable orbit without consuming a lot of fuel. But if you want to maintain that, you have to sort of nudge yourself backwards and forwards to stay right in that same spot. This is L1, which is on the sun side of the Earth. James Webb Space Telescope is on L2, which is on the other side of the Earth, facing away from the sun because you don't want it to be blinded by the sunlight. But we do put things that want to look at the sun at L1. They don't face the Earth, they face the sun. So Solar Dynamics Observatory, stereo, those we put at L1. And when they ran out of fuel, we let them drift. And stereo had two. There's stereo A and stereo B. You need two channels for stereo. And one of them went out of communication as it went behind the sun in its orbit, and we never heard from it again. And the other one, stereo, I think it's stereo B, went behind the sun, came back out again, and we're still talking to it. So L1's a good spot. The problem is when you put it out that far, you're not about to do any repair work or sustaining on it, and it's going to have a lifespan of about 5 years before it runs out of orbiting maneuvering fuel. Not a good idea, but you can do it for a limited time. How about we reduce our goals? We said, well, I really only want to block a small area. And if I block a smaller area, maybe I can put it up in the mesosphere, that thing we talked about a couple of weeks ago, where they're looking at creating not quite orbiting spacecraft, but hovering high altitude craft for observing things. If they made a small enough disk that might only be 100 miles across or something, maybe they could cool limited areas like a field that's getting too much sunlight and cooking the crops, or do it right over the top of a tropical storm development area to cool it so that the hurricane didn't form. Or when you see, it looks like this afternoon, a big tornado is going to form, you move it over the top of that, it cools off the area, and no tornado. You can do those kind of things. But if you did something like that, now the cost of doing it is more modest, and maybe you want a fleet of these things and have them available to go look at other things, do it for other purposes. So let's take a look at just one of these. What would it be? It'd be smaller in diameter. It may only be hundreds to thousands of feet in diameter, which is still large, but we have satellites that have antennas up at geostationary that do have 1,000-foot diameter dishes that open up. We have the technology to create something like that. Does it have to fully block the sun? If the area you're concerned about is closing on 120 degrees, maybe knocking it down to 95 degrees is sufficient, and you may not need a complete obstruction of the light to do that. You might diffuse it. It might just be an open grid that's just solid enough, or you might even have like LCD shutters that you can turn on and off to adjust how dark you want it. You might want to deploy it over a location by a certain time period and then let it hover or loiter over there. And then later on, it goes over and does another mission in different places. Think of it as how would you mitigate a tropical storm or a hurricane or a tornado or just a heat dome? You put one of these things up over the area for a limited period of time, just long enough to mitigate whatever you're trying to do. If you remember Star Trek: The Next Generation, they had this thing that they came up with called the weather modification net. If you had a lot of these things that you could fly around as you needed them, they would be the Earth's weather modification net. Okay, I'm only going to give you one slide worth of math. You can have the aspirin on standby. If the area that you want to darken is the lower disk, the A when they're in the middle, and the Earth is that blue thing beneath it, it's not water, it's just Earth. To calculate how big a disk you would need at what altitude, you essentially make a giant triangle, and then you go back to your high school trigonometry and you make calculations to judge how high would it need to be and how large would it need to be. And the sad answer is it's not going to get there with simple trigonometry. You actually need calculus. And I didn't want to get into that, so it stops at the point where, okay, we can calculate the height from the surface at the diameter that you want down to the point of the cone, but we don't have enough data to just do a simple cosine or sine or something like that and come up with the number for H1 and then the diameter for R2. But we can calculate, H2 and S2 and all those kinds of interesting things. But if your brain is whirring enough, you can look at this slide later on and check my math, as the saying goes. But yeah, I couldn't calculate it directly without calculus. Not that I'm bad at calculus, I'm just more versed in trigonometry than I am in calculus. And don't get me started on integrals. So maybe the best approach is to have a small fleet of these things that they could go and be used to either block or diffuse a certain amount of sunlight, not all of it, but a certain amount of sunlight over an area. But how much would you need to block? Well, if you only wanted to drop the temperature about 4 degrees Celsius or 15 degrees Fahrenheit, that might be a lifesaver or a cost saver or a crop saver to just dim it down a bit. It doesn't have to like freeze the area, it just has to dim it down. That would be useful enough. So, what size disk and what altitude you would need it at would need some research, but maybe to save a field of crops, maybe to save a city from, people passing away from being overheated. Maybe that's worth a few $1,000,000 to research it and develop it. Or maybe think of it as, if I reduce the heat over a large agricultural region, I reduce also the water consumption of those crops to keep them alive and well. So it's a water saving thing. So how would you design and develop this thing? Well, obviously, you're going to need a lot of space to put one of these things up on the ground to do all your calculations. And maybe you want it to be tested out on the ground and then fold up, go into something that you put up in maybe not in orbit, but high altitude, and then it opens up again. That way it makes it much simpler to get it up there. You don't have to lift a giant disk. Obviously, you need some kind of propulsion to keep it loitering over the area that needs to be on. But if it's up high enough, there may not be enough air for you to use combustible fuels or propellers or things like that. And you might need that stuff we talked about a couple of weeks ago, where they take sunlight and use the sunlight to ionize pressurized, very thin atmosphere to use as an ion thruster to get this thing to be in the right spot. Maybe you help it out a bit. Maybe there's helium balloons around the outside of it to help lift it to get it up there. But it would need some kind of inertial navigation system to know whether it's over its target location and how to stay there. It might need to be there for a few days to a week at a time. Obviously, it's only important during the daytime, but it may need to loiter for a little while during a peak heat period or for a hurricane development of a specific hurricane. Obviously, you could put photovoltaic panels on this thing to get electricity from it. But you'd need batteries on board to sustain whatever maneuvering it's doing on a cloudy day or at night. When you go to deploy these things, how do you go about sending it to where it needs to be? Obviously, it needs some ability to get up there. But once you have it up there, maybe and when it's done in that area, just have it go do station keeping out over the ocean to offer a general cooling of a certain small area of the ocean. You do enough of these in an armada of them, maybe you can help with coral bleaching or something. It's just a public service. Obviously, it only works in the daytime because that's when the sun's out. It doesn't need to be there from sunrise to sunset because just think of it as the hottest part of the day. It could move overnight to a station that it needs to be there when the sunrise occurs, track over the area, and then as soon as sunset occurs, maybe move to another area or to just hang there overnight in case it's going to be hot again tomorrow. But to do that, you'd need a small fleet of these things. And also, you want some way to have maybe tiny holes through the covering disk, because if you covered it above an area, the heat from the ground will actually push you up because you're a large air wing. So you need to let the infrared heat up through your disk. What about public safety? Won't people we don't want this because it might break up and fall on somebody's head or destroy property on the ground or be an obstacle to other aircraft if it's taking off as a full-size disk and you have to get the FAA clearance. And maybe if one of these things comes down, you want it to land on an unpopulated area for recovery out in the desert, a nice flat open area. Or maybe you build it from modules and it assembles when it's up at altitude. And then when you want to bring it back down, it disassembles itself and they come down individually, land on runways or something, or parachutes. So what is the reason for doing this stuff? How do we cover the probably immense millions to billions cost for doing this development and deployment and such? What's the return on investment? And is there some way that will affect taxes, governmental income? Well, when you put it up there, and it cools something, that's a change in what's going to be happening on the ground. If you do this as a government entity, you can provide it as a service paid for by public appropriations, meaning tax dollars. If you do this as a commercial business, then you're going to have private investors. But now once you get it up there, you need to get revenue from it. So you could offer it as a cooling service. And who would license this thing? And if you got it up there and it was providing service and was taking in revenue, wouldn't somebody want to tax that? If it's taxed, is that state tax, like sales tax, which is different in different places? Or is that a federal tax? Things to think about. And then once you got it up there, shouldn't it be insured for liability in case something goes wrong, or you have to, like, it falls out of the sky, doesn't hurt anybody, but falls out of the sky and you've got to build a new one? That's going to cost you money. This is an interesting take on it. Solar heating mitigation as competition. In the US, except for the Tennessee Valley Authority, most power is generated by commercial entities. Florida Power & Light here in Florida, for the most part. If you suddenly blocked out the sunlight, and that happened to be over an area where FP&L had a large array of solar panels, your benefit of blocking out the sunlight to help an agricultural area out in the middle of the Everglades is going to be deterring their ability to produce more electricity. So you're going to impact their revenue stream. So, you got to think about how the revenue effect is going to occur. And you'd like to reduce consumption. But if you said, I'm going to reduce the water consumption of a community or an agricultural area, that's skewing the public utility, because the public utility expects a certain level of revenue during the summertime based upon consumption of water. And if you're darkening things, that reduces the consumption of water, and therefore your public utility doesn't make as much revenue. So I can see legal actions here of, you think you're doing a good thing, but you're hurting somebody else's revenue, or you're adjusting some tax source. And once somebody puts this and says, we think we want to do this, either as a government or as a commercial enterprise, expect the legal actions to come out. And what about the effect on solar power for communities or homes? If you said, I want to cool off Phoenix, Arizona, and it's just a city. I'm not going to do the whole state or all of North America or the US, just Phoenix when it gets to be above 112 degrees. There's a lot of homes out there that generate power from the sun. And by darkening the area, you're going to be reducing their ability to generate power. What's the trade-off? Because when you reduce the sun, you don't need as much power for your air conditioning. So it's a formulaic kind of thing. The effects on the weather, if you have experienced a solar eclipse and you notice that the cloud pattern changes as the area cools, and then when the sun comes back out, the cloud pattern changes again. And if you do that over a desert area or a large area of mountainous or rocks that are exposed, as you cool the area, the ground level temperature could drop too rapidly because there's a lot more sand or rock down there. And so when you darken it, it dips precipitously, and you might change rainfall patterns. You may have to think about, if all of a sudden it's getting too cool, you may have to move away, let the sun heat it back up, or you may just, tilt it slightly to let some sun in, or louvers open, or if you have LCD arrays blocking the sun, make things more transparent. But I think they'll figure it all out once either a government or some commercial entity starts doing this, because we're figuring this stuff out today. The financial models and the taxation models and how to deal with this over small and large areas. Electric vehicles, they're realizing that if you put too many electric vehicles on the road, that reduces your gasoline tax, and your gasoline tax helps fund maintenance of the roads that the vehicles are driving on. So they're increasing vehicle registration costs for EVs in some states to compensate the state's budget for what they're not making on gasoline tax. Solar power is the same sort of thing. If you have an area that has a lot of photovoltaic cells on the roof, they're taking their source of power, which costs them nothing except the equipment, the installation, and maintenance, and they're putting that on the grid, which reduces the power companies' need to expend fossil fuels to produce electricity. But if all of a sudden you produce too much power, now it's how does that balance out from a taxation and a revenue perspective? if you've made a private investment for your dimming work, how does that affect the residents and the government and other businesses in the area? And what might be the investment for that? So I think that they're figuring out that there are big systems, and you've got to, when you push down all of the whack-a-moles, that other whack-a-moles will pop up. So I think they figure these things out eventually. But what if some entrepreneurial company realizes that this is something that's technologically feasible and there's likely to be money on the table that they can get? Then you might find that, the parent company of FP&L, NextEra, when they realized that photovoltaics are a great way of offsetting the cost of natural gas for firing up their power plants, they invested over $1 billion in photovoltaic cells and battery in Florida to offset natural gas costs. You've got a system here, and once they realize the revenue potential or the cost savings potential, you could find that the likes of a NextEra or a Mobile or some very large entity that would have the billions of dollars in pocket lint to fund this kind of activity, they may create the technology. And if they do create the technology, the first thing you're going to think of is, how do we patent this? Well, if we can't patent the physics, then maybe we can patent the business model of doing this for a service. And there are already patents for those kind of things for the likes of Amazon and PayPal, et cetera. So maybe they can, find roadblocks. So they're the first and only company that does this up until their patent expires. And then you have, lawsuits to break down patents and such. And they can expend the money that they have to make sure that no competitors come in, and they have a good lock on things. So that will create a monopoly. But if a corporation comes in to do this, and all of a sudden they're making across the earth billions of dollars for what maybe cost them hundreds of millions of dollars to establish, and they can offer it as a service, don't feel so outraged when all of a sudden they're making billions of dollars for something that you didn't think was feasible or practical. So there is an alternative that has been proposed, not by me, but by others in the scientific community, of why don't we just inject chemical aerosols into the atmosphere over the areas where we want stuff to be cooler, like oceans. Go out over a large ocean area and just have a bunch of airplanes squirting out aerosols into the upper atmosphere, and that will very slightly darken the area. But they've modeled it to know that it will make things cooler. Exactly how much cooler, for how long, over what size area, and how much it'll cost, and how many planes you have to fly, and how often you have to do it. The practicality, the deployment and operation of it is something that's still open. They would not be able to do this fast enough to deter a hurricane, but they might be able to cover an area large enough to deter a hurricane season. Adam?
They were going to do it from ships, so as opposed to planes. So then they would just pump up, aerosolize the seawater and blow a big plume of it behind ships.
Right, but think of it as, if you do it from the ocean and you're using ships don't get to an area quickly. So if they're going to do it from a ship and you're trying to deter a hurricane, how long will it take for your ship to get there to the site where you're going to, push the aerosol up? And then how long does it take for the aerosol to rise up high enough to drop the ocean temperature enough so that the either hurricane doesn't form or the hurricane doesn't get as bad as you thought? So they've got models, and they're thinking about stuff, but I think that they're not thinking on a large enough scale. And once you do get this up into the atmosphere, you've got the jet stream to deal with, which might push it out before it has the effect that you desire. And what are if you're just pushing water vapor up, the water vapor is going to become clouds. It may actually affect the weather, or it may descend too rapidly based upon sunlight, and you won't get the effect that you need. I don't think aerosols are the answer, but keep looking into it. I think darkening via some kind of airborne covering is probably more practical. So anytime new science comes out there and tries a capability, you're going to have sort of knee-jerk responders that come No, that's not technologically feasible. Sure. And how long do we fly rockets before somebody said, I think we can land the booster back on the ground or on a ship at sea? Uh, Not technologically feasible until somebody actually makes it technologically feasible. This thing is going to fall on your head and destroy property and, destroy cities. And like, nobody seems to have a problem with the Goodyear blimp flying over a stadium filled with people. How big is a 747 aircraft? And if one of those comes out of the sky, the very enormous geostationary satellites that are up there in the sky for hundreds to maybe thousands of years, yeah, they're still up there. There's not enough fuel left to bring it all the way back down, but they're still going to be up there. Nobody seems to we're going to run out of slots eventually. Maybe we can't change the whole planet, but maybe we can change it for a small enough area, but large enough to be significant, like deter a hurricane, deter a tornado, a bad tropical storm, save a crop area, reduce a city in Saudi Arabia that would otherwise be a health hazard because it gets to 125 degrees. Maybe you could drop it down to only 112 degrees. Is it going to disrupt things, businesses, governments, tax bases? Yes. So if you realize it might change things, do you not do it because change is hard? No, of course you're going to do something, because if you don't do something, that's going to be a problem. Do it with aerosols? Well, maybe, but you can't do everything. Or as a friend of mine likes to say, you can't boil the ocean. It just takes too much energy. But what you can do is, over a small enough area, maybe there's something you can do, and maybe corporations or governments or DARPA or somebody will figure out that we should start a pilot project just to see how feasible this is. In other words, do the rest of the math. If you have an entrepreneurial group that says, we think we want to expend our millions of dollars or billions of dollars to figure this thing out and to do it, if a government does it with your tax dollars, I'm sure there are people that are in decision-making positions that will decide that as your representative government. Or if it's corporate, I think that, corporates are going to be willing to spend the money to save the money or to make the money. They can save the money by not having to produce the power that they don't want to produce, or they can save money by saving yields on crops and such, or maybe they can use it as a service and say, hey, if we go over your agricultural area and we drop the temperature to the point where you don't have to spend as much money on water, because now they're taxing water for large agricultural areas where it's a large community draw, maybe that's enough to offset things to make it worthwhile to provide a service. If you said, as a commercial entity, I have the FAA approval to fly one of these things over a developing hurricane to make the hurricane not develop. How much is that worth to an area that was on target to be hit by the hurricane? Well, it might be millions of dollars in, disaster recovery. Maybe lives can be saved, or maybe, insurance money could be saved. And I'm sure that the insurance companies that have to spend billions of dollars on repairs due to tornado or hurricane damage would love to spend only a few $1,000,000 to get it mitigated for them. And the one that just like on the cutting edge was, there's a lot of ski resorts that very wealthy people go to, and they can't go to those ski resorts anymore because the snowpack isn't large enough because it got too hot. Well, if you could dim things down a bit when a snow front was coming in, maybe you could have it produce more snow and you get all that ski resort tourism revenue back up to where it was. So maybe it's worth a few $1,000,000 for you to have it come by and, darken things a little bit. So there's money to be made there. Don't leave it on the table. So in conclusion, do I think that such technology and craft will happen? I think it will, yeah, because we're on a path to things getting warmer. And if this can mitigate the warming and make money off of it, yeah. Do I think it will be beneficial? Overall, yes, but I think there's going to be some downsides that are going to have to be reevaluated and balanced. Do I think it would be profitable if a corporation did it? Absolutely. Saving crops, saving water, saving insurance costs. There's money to be made there. Will this effort solve the climate for the whole of the earth? No, it won't be large enough to do that, but it may help certain areas. Have I uncovered all of the nooks and crannies associated with this, whether they're emotional or factual? No. I've touched on some things that I thought of that most people might not think of, but that's just me. Do I think that this is a better solution than various forms of aerosols? I think it's a more controlled solution, a more manageable solution, which makes it a better service offering. Do I think we'll not really know how this is going to fly until we try it? Yes. So what is required right now is the vision, the willingness to try it, maybe the millions to small number of billions to develop the technology, maybe do a trial deployment and see how it's going to work. Typically, that kind of investment and research is the job of governments, not of corporations. Corporations usually come in once, DARPA figures out how to do it, and then Boeing comes in and says, we can build a craft for you. Cut us the check. The Earth is not getting cooler anytime soon. And if there is a successful business offering, I think there's a revenue potential, but we won't really know until somebody tries it. But as it gets warmer, if there is revenue, it'll only increase over time. And as usual, lots of links. I've included the links for the math in case people get interested in what's a frustum? And triangle? Does that mean the triangle is golden color when it's golden triangle? No, it's just the ratio of the base to the sides being the magical golden number, 1.616 something. Lots of digits. And then I did include a couple of articles, etc., for blocking the sun by aerosols. People don't know that this is a business that's already out there. In agricultural areas, there are corporations that have millions of dollars invested in cloud seeding, and they offer it as a marketplace. Hey, Mr. Farm owner, would you like your a little more rain out there? And they will charge you a not guaranteed service cost for them to silver halide seed the clouds over your area to give you a little more rainfall or to move the rain somewhere else in case you're saturated. But if there are no clouds, if there's not enough humidity in the upper altitude, there's nothing to seed. So you could want it, you could be willing to pay your millions to do it, but if they don't have the underlying water droplets in the upper atmosphere, there's nothing to seed. And then my video from a week ago being Otter, the DARPA program about mesospheric long duration flying craft. So once again, I thought this was a nice kind of somewhat diversionary, but also, not direct to astronomy kind of thing. But it does have to do with the technology and putting things up for a long duration and that kind of thing. But I got hooked on it and went down the rabbit hole and thought of all these side avenues and, corporate revenue, balancing it out of generation versus consumption and taxation and how it's going to affect government revenue systems, and just kept digging deeper and deeper. And
yeah. Well, thank you very much. This never really occurred to me that we could create these.
The technology to create the disks is there. And as an example, those geostationary satellites that are very high in altitude, you've got maybe 1,500-foot radius dishes that are radio antennas, but there's nothing that says that they couldn't make that a more solid disk or close louvers on it and darken an area below. And if you move that closer, if you have the propulsion technology to move it closer and to hover over an area, you may not, convert it from daytime to nighttime, but if you convert it from 120 degrees down to 112 degrees, that may be very worthwhile for a revenue source.
Yeah. It's just never occurred to me that you could do that.
Well, that's why I do the stuff that I do, because, I think 5 impossible things before breakfast.
It's amazing. Thank you.
But other people are thinking of it too.
Well, obviously the aerosol folks are, but I don't think the disk folks are. because everybody starts with the premise that you've got to have a disk big enough to cover the entire Earth. It's going to be way out in space. And why don't you start with like something smaller scale? How about I'm going to protect your agricultural area from consuming more water than it needs to? Or I'm going to go fly out over in the Caribbean and I'm going to lessen the impact of a hurricane. Or I'm going to move a hurricane. I'm going to redirect it. But then you have the insurance liability of, hey, you moved the hurricane away from the tourist resort that paid you millions to our third world island nation that couldn't afford to do that. Like, yeah, you got to think about those things. But I'm a minutia oriented individual, so there's not a rabbit hole that I can't find and spend time going down.
Couldn't you unfurl something, or rather even than unfurl? Yeah, like set up a something that's only a few millimeters thick that's got an albedo. What's the word?
Albedo, yes.
Albedo of 1, and you just unfurl it in space, like the way they unfolded the James West Telescope, right? That you could roll something up as a cylinder, and maybe have it roll out and then pop open triple wide, and be reflective that way.
If you go onto YouTube and you search for opening in space or unfolding in space, you'd be amazed at the clandestine satellites and how large their radio antennas are, and they're already up there in low Earth orbit. You just don't know about them because it's not a lot of public coverage over those, U.S. National Reconnaissance Office satellites. And yeah, we for a long time had the technology to create enormous mylar dish antennas. We're going to pick up every cell phone in Iraq, and then we're going to filter out what we want to listen to. So, yeah.
So right, mylar, that's the stuff. Mylar, and you can get mylar balloons that are covered with, I don't know what makes them shiny, maybe aluminum powder or something on it, but right, so I think so. The big problem is that we're so far from the sun relative to where we're putting it up that it's not really spreading out over a very big area. That the sun being 93 million miles away, that if we put something up that's 1 acre of area, it's only going to cover slightly over an acre on Earth, right?
More than that. For example, here's a good example. You go to the beach and you rent an umbrella. It covers you and whoever's with you, a couple of people on the ground. How big is the umbrella and how high above the surface of the Earth is it? It's small and it's maybe 5 feet. Now, make that 1,000 feet across. How high do you need it to cover 100 people on the beach?
Not very.
Right. So imagine that you could create something that was a couple of miles across and you brought it up to, let's say, 45,000 feet. Would that be enough to save an agricultural area?
I think the idea would be to get a lot of those are a continuous area that would be over the ocean during the daytime, and or as much time as possible as a general solution to bringing down the temperature of the ocean and reflecting the sun. As far as an individual area, that's true. I think there are many cities. I'm sure Miami Beach during these really hot days would pay for some technology to cool it off. I'm not so sure that they would pay for a technology that brings midnight to the middle of day, though.
And that's why I'm saying you have to be more modest in your request. And I think that will make it technically feasible, deployable either a government or business entity, and that will be successful. But you're right that you can't do it with just one. You probably need an armada of these things as a service. And if you want a larger area, you put up multiple of them at slightly different altitudes, offsetting one another to diffract the light, so that at the ground, it's not dark. It's not like day versus night. It's more like noon versus 9 a.m. I think if you start with a modest goal, you can have technically feasible and test deployable rather quickly. But first,
And
you have to
these
have the envisionment and a few dollars behind it.
won't interfere with satellite communications.
See, now there's something you're thinking about that I didn't think about was, is this thing radiolucent? Is it transparent to radio waves? Because if it's not, you're going to be blocking out Starlink coverage. Because remember, Starlink coverage can be blocked by trees blowing in the direction of the satellite. And that's where one business's revenue is being obscured by another business's revenue. Yeah. So any other comments or questions before I stop recording? Hearing nothing.